So today we will talk about the standards-based classrooms and what does it look like, what is the role of the teacher, how do we support the students in this type of classroom. So today's objectives. Today we will identify and describe students' roles in the math classroom, describe logical learners, describe collaborative learning, identify and examine two learning theories that are used in the classroom, and identify the importance for technological tools in the math classroom. So what does a standards-based classroom look like? First, it is all about the students. A standards-based classroom means a student-centered classroom. And so students need opportunities to work in small groups, work on long-term projects and/or investigations, have access to mathematical tools and technologies, present and discuss solutions to problems, and again this can be in small groups or within the whole classroom, and write solutions that show their thinking and/or reasoning processes. And remember from when we were talking about the history of mathematics education reform, we discussed how we want our students to really problem solve, to get into the process of thinking and reasoning so that they can come up to a solution. We're more concerned about the process than the solution in the standards-based classroom. And then we also want the students to participate in assessment activities, including self-assessments. We want our students to show that they really can apply their understanding and their skills, and also for students to self-assess. What did they learn? How do they get to that solution? What do they want to learn in the future? So logical thinkers, students need opportunities to justify their answers and explain the process to solve problems. We just don't want them to get to the answer and then move on to the next problem. We want them to explain the process so that other students can understand that process. Maybe that process will work for students who are having a hard time. So just sharing the process is beneficial for both students. And it also helps students explore and understand the value of applying logical thinking outside of mathematics. Again, we want students to know that what they're learning can be applied outside of the classroom, outside of math, that we need to know how to problem solve, how to use these skills, even in the college, when they go to college or in their careers. Now there are two types of reasoning. There's inductive reasoning and deductive reasoning. In inductive reasoning, a person will observe data, recognize the patterns, and make predictions. And so when they first recognize the patterns, they will make a prediction, and sometimes this reasoning, it can be valid and sometimes it cannot be. Sometimes it cannot be applied in all cases. So for example, let's look at the numbers that I've provided below: 5, 10, 15, 20, 25, 30. Now looking at the pattern, it's obvious that we are adding 5 to each number. So we would continue. The sequence would be 35, 40, 45, 50, and so on. That is logical. However, this situation could be on observing plants, the growth, and writing down the growth from every 5 days or every 5th day. So this could not work, because if we are observing the plants on the 5th of the month, the 10th, the 15th, the 20th, the 25th, 30th, there's only 31 days out of the 11 months of the year. So we can't say, okay, on October 35th, we're going to record the plant's growth. Instead, we would have to go to either the 4th or the 5th of the next month, depending how many days there are, even on the 20th or 29th day due to February. So although we recognize a pattern and we can reason why we can make the prediction of just adding 5, we have to look at the situation also. Now deductive reasoning starts with a true statement and then other logical statements follow. For example, no felon can be a teacher. Jim is a felon. Therefore, Jim cannot be a teacher. And so the true statement is that no felon can be a teacher. And then there's other logical statements that will follow, and this deductive reasoning in this situation is valid. Now, there's also deductive reasoning can also be, although justified when just looking at the sentences, it can be invalid. So, for example, everything that is round is a ball. Well, the earth is round, therefore earth is a ball. Now, just looking at the facts, and if someone doesn't know what the earth is, we can say that that is correct, that it is a valid statement. However, because we know that earth is not a ball, even though we could justify it using just the facts, it makes this deductive reasoning invalid. So mathematical collaboration. It also means cooperative learning, and this is when we have students working together for a common goal. And in cooperative learning, we encourage our students to use mathematical language. We want our students to think and talk like mathematicians. In my classroom, we called it math talk, and I had a big chart paper on the board, and every time I heard a student using a math term, talking mathematically, I would write those words on the board so that the students can continuously use that, start practicing it, so that it would become automatic. And so we want our students to really use a mathematical language to show that they understand those terms. And also in cooperative learning, we want our students to use logic reasoning. We want our students to justify their answers, to use inductive or deductive reasoning to come up with conclusions. So we'll talk about some learning theories. B.F. Skinner's behavioral theory, his behaviorism theory is very popular and very well used. But in education, especially in the math education, we are now shifting away from the behavioral theory. Before, students were just memorizing facts. They were just in participating arithmetic, where it was just get to the answer and move on. And so students were participating in the rote learning methods. Teachers were providing those methods, and the lessons were objective. It only had one answer. Yes, there was a process, but it was more focused on getting the correct answer. And so the problem was, could students solve problems outside of fast calculations? There are a lot of problems in mathematics where there could be multiple answers, and so we would have to look at the process they went through in order to justify their answers. And so if students could only just calculate but couldn't explain it, or couldn't understand how it worked, this was not beneficial to the students. It was more detrimental to the students' thinking. So today we use more of the cognitive psychology. We're connecting math to the outside world. It's not just solving 2 + 2 = 4. We're really connecting math to the outside world by using word problems and allowing students to hands-on participate in finding solutions. And these solutions could have more than one answer, as long as they could justify their reasoning. So the students also use knowledge and experience to solve a rich problem with many solutions, and using this knowledge and experience and having been exposed to rich problems, the students will also better understand math concepts and the processes, and then the students will have stronger confidence to solve future problems. Once they can apply it to these different math concepts, they know that they will be able to apply it for future problems. And the use of the cognitive psychology also supports the use of manipulatives and technology. So why is technology important? Technology allows students to explore and identify math concepts and relationships, and then also supports the learning of mathematical procedures and skills. And this is where differentiation comes into place. While students are all on different levels, technology, there's so much technology out there that students can work at their own pace, can go above and beyond their advanced mathematical abilities in the problem solving, reasoning, and justifying. So I have listed some technological tools that you can use in your classroom. So please save these websites and bookmark them on your computer. For computers and calculators, Illuminations is a great resource for teaching math, and this is from the website of the National Council of Teachers of Mathematics. And then also the Texas Instruments activities. Using this website, students can go into a lesson plan, and then they go into a lesson and they can use their calculators, TI calculator, to solve problems. It's really great, and it will, again, support and encourage them to think about the process. And it's all about the trial and error also. If it doesn't work this way, let's try another way. And then the NASA Education for Students is a great website for students to look into what NASA is about, and also there are interactive activities students can complete. And also keep NASA in mind as a possible future field trip for your students. They welcome students and teachers to come in and tour the place, to talk about what NASA does and what kind of employees they're looking for in the STEM area. And so I also have listed some applets, tools, and simulations, and resource for females to encourage females to get into the STEM programs. And so Math Applets is great. It's very interactive, and you can use the iPad, iPhone, any modern device, and a lot of schools now have iPads for each student to use in the classroom. So please check that out. And then tools and simulations that students can use to graph and to create simulations for airplanes, and very hands-on, and helps motivate students to think about what they would like to do in the future. And then resource for educators. This is the 10 best STEM resources that National Educators Association provided. If you are not a member of NEA, please sign up and be a member. They have great tools and resources for you to support your student learning. So for week 2 and 3, we'll talk more about computer programs and calculators and abstract, having students think from concrete to abstract with the tools and manipulatives, and there'll be more hands-on activities for you to explore the different types of technological tools.